Good morning, this is Beer Money Adventures, and I'm Nick. And today we're going to be going over the basic setup and configuration on a Fisher FloBoss ROC 503. I'll go ahead and get connected to it and we'll get started. The main components of the meter are the transmitter, the main board, the communications board, the batteries, the LCD screen, and then here on top the radio. The direct connect port is on the bottom left side of the box. I will remove the cap and connect the cord to the meter. I will use the direct connect tab here at the top of the screen to connect the meter to the laptop, and then I will work through the basic setup points to configure the meter. I will start here with the View tab and scroll down to the I/O monitor, and then I will click on Meter Flow Values. Here you can see the first line is the uncorrected flow rate, which is the differential pressure. Next is static pressure, and then temperature. A couple lines down from that, we've got the flow rate per day, which is an instant flow rate. And a couple more lines down from that is yesterday's flow. I use this to get a flow volume for the full day. Next I will go to the ROC tab and scroll down to Clock. Here I can set the date and the time on the device. You can click on this red circle and it will use the date and the time from your computer, or you can manually set the date and the time off of the calendar. Next I will click on the ROC tab and scroll down to COM ports. COM port 1 is going to be the port used to connect directly to the meter with your computer, and COM port 2 is going to be the port used by the radio for telemetry. It is also important to verify that your baud rate matches with the device communicating with the meter. Next I will click on the ROC tab and scroll down to Information. Here I will type in the name of the station. Below that is the address and group. These are the numbers used by automation to remotely connect and collect data from the meter. The contract hour is the time of day that the data will be collected. From there we will move on to the Configure tab and go to I/O and then over and click on the AI points. The first analog input is the differential pressure. From here you can adjust the span. If you do adjust the span in this tab, the meter must be calibrated before the meter is returned to service. The second AI point is the static pressure. Here you can also adjust the high and low points of the span. The third AI point is the RTD, which is used to collect the input from the temperature sensor. From there I will move on to Configure and scroll down to LCD User List. In this tab I will configure the information that will cycle across the LCD screen on the meter. This information may vary due to what the lease operator requests. Starting here at 1, I will work through the list, giving each line a description, and then choose the parameter that the meter pulls the value from. Number 1 will be differential pressure, and the parameter will be 46, 1, and 51. Number 2 will be static pressure, and the parameter will be 46, 1, and 52. Number 3 will be line temperature, and the parameter will be 46, 1, and 53. Number 4 will be flow per day, and the parameter will be 47, 1, and 0. Number 5 will be 7-day flow, and the parameter will be 8, 1, and 27. Number 6 will be flow per month, and the parameter will be 47, 1, and 38. Number 7 will be the meter name, and the parameter will be 46, 1, and 1. Number 8 will be the meter number. The parameter will be 46, 1, and 0. Number 9 will be the plate size. And the parameter will be 46, 1, and 10. Next, we'll click on the meter tab and scroll down to Setup. The meter tag is where I will type in the meter number, and the meter description is where I will type in the meter name. Here I will enter the pipe diameter of the meter run and the orifice plate diameter. The low cutoff is the minimum differential pressure that the meter will record flow volume. Any value under the number entered will be zero flow. Next, I will move on to the gas quality tab. It's important to enter an accurate gas analysis into the meter because it will affect the flow rate. Once I have a complete analysis entered, the total mole percent will be 100. Here I will enter the heating value and the specific gravity. These numbers will also be obtained from the gas analysis. I will now move on to the Advanced tab. Here I will enter the base pressure, base temperature, elevation, and the atmospheric pressure. I will also need to set the pressure tap. This will determine if the meter will be measuring in gauge pressure or absolute pressure. I'm now ready to calibrate the meter. I will click on the Meter tab and scroll down to Calibration. Here I will freeze the meter and create a calibration report. I'm going to start the test by verifying the static pressure. So I will connect my test equipment to the high side of the transmitter and close both isolation valves. Open both equalizer valves and close the vent valve. I will go ahead and choose Verify here under the static pressure. The static pressure sensor on these transmitters come in two different variations: PSIG, gauge pressure, or PSIA, atmospheric pressure. This meter happens to be PSIA. So as we start the meter verification, you will see that with no pressure on the meter, 0 is 13.2. I will use the crystal to verify that there is no pressure on the sensor. The first test point will be 13.2. I will type that in as the test value. I like to see the deviation under 0.1%. The company that you work for will give you limits on the maximum allowable deviation. Next, I will use my test equipment to pressure the meter to 50 psig and the live reading should be 63.2. The third and final verification point for static pressure will be 100 psi-G, which will give a live reading of 113.2. After I verify the 3 test points, I will calibrate the static pressure transmitter if needed. I will calibrate the static transmitter at 3 points: 0, the chosen span, and 1 midpoint. The span on this meter will be set to 100 psi-G, which will give a live reading of 113.2. The midpoint will be 50 psi-G, which will give a live reading of 63.2. After the meter has been calibrated, a verification needs to be done before the meter is placed back in service. I will verify the static pressure transmitter at 3 points. You can see here that after calibration, the live reading is very accurate with 0% of deviation. Once the static pressure has been calibrated and verified, I will move on to verifying the differential pressure transmitter. To prepare the meter for differential calibration, I will open the vent valve and close the equalizer valve on the high pressure side of the manifold. I will use the low pressure side of the crystal to test the differential transmitter and use inches of water column as unit of measure. This will show up as inches of H2O on the crystal. I will verify the differential transmitter at 5 points. The 5 points will be 0, 50, 100, 75, 25, and then returning to 0. After I have verified the 5 points on the differential transmitter, I will move on to the calibration. The differential transmitter will also be calibrated at 5 points: 0, the span 100, and then midpoint 75, 50, and 25. Once I have completed the calibration, I will finish by verifying the 5 test points one more time. If the verification is within spec, I will move on to verifying the temperature. Once the static and differential calibration is complete, I will prepare the manifold for the meter to be placed back in service. I will open the red vent valve, close the two green equalizer valves, close the valve to the test equipment, and last, open the two blue isolation valves. Next, I will verify and calibrate the temperature by using an RTD simulator. To connect the RTD simulator to the meter, I will disconnect the temperature probe on the lower right-hand side of the main board and connect the RTD simulator. I will verify the temperature at 3 points, 0, 75, and 150. I will set the test equipment to 0 and then verify the live reading. Then I will move on to verify 75 degrees, and the last verification point, 150 degrees. From there, I will go ahead and calibrate the RTD at 3 points. First, I will calibrate the RTD at 0, and then I will calibrate the span at 150, and last one midpoint of 75. Once the calibration is complete, a verification on the 3 test points will need to be done. Now I will go back to Configure and scroll down to I/O and then over to AI points. From there I will scroll down and choose RTD. Here you can see that after I calibrated the span on the RTD to 150, it changed the span on the AI points from 212 to 150 automatically. The static and differential AI points will change accordingly also if the span is changed during calibration. Now that I have finished calibrating the RTD, I will remove the test equipment and reconnect the RTD temperature probe. After completing the calibration and realizing that the transmitter operates in PSI-A, pressure per square inch absolute, I need to go back to the meter tab and scroll down to setup. I then need to go to the pressure tap box here at the bottom and change it from gauge to absolute. Then click apply before closing the tab. Once the meter setup and calibration is complete, I will go to the ROC tab and scroll down to Flags. Here I will click on the Save Configuration tab and then choose Yes. This will save the meter configuration to the memory on the meter, so that if the meter loses power, it will not lose the configuration or the calibration. The last step should be saving the meter configuration to your computer. Do this by clicking on the File tab and scrolling down to Save Configuration. If the meter does lose its configuration, you will have it saved on your computer and can reinstall it quickly by clicking on the File tab and choosing Download. Here you will want to choose Select All and then click Download. When you reinstall a configuration, the static differential and temperature will need to be verified. Thank you for watching, and I hope this video helps you as a natural gas measurement technician.